Hello there, and welcome back to another day where I have some free time. And in this day's video of unstd-c, we'll be continuing on with the implementation of malloc. So let us get started. And I believe that's in standard lib in malloc.c. So first, I would like to move the structures into its own header file. So just call that malloc internal or something. And might as well create some header guards. So if not defined, um, malloc internal h, oops, and I've gotta add an end if over here, and that is that. And while in here, I also need standard def for size t, and then I gotta add the internal malloc header over here. Well then, the other stuff that we will need over here is, well, if there's a need to add a new heap data structure over here, we should also check if the size is within the new one that we'll be using mmap for. So we gotta do that. So if size is greater than or equal to 4096, then we should be doing something else. Wait, no. Instead of that, I'll be doing this in reverse. If the size is less than 4096, subtracting the size of the, um, I guess the headers for the chunks we'll be adding, plus the size of the other one, the heap data as well. So we gotta do that. Heap chunk over here. And then if the size is greater than that, we'll map the actual size of the allocation that the user needs plus the size of heap chunk type. Now, since there's a difference in size now, well, you gotta add those as well. So I guess there will be two ways the map fails now. And the size of this allocation will be size plus I guess the size of the heap chunk type. Also, in our size checks, the size must not only be greater or equal to the size over here. But the size, well, the chunk data size should also be able to, I guess, n- what do you call this word? I forgot it, but that's right. Accommodate. It should also accommodate the size of our headers, which is the heap chunk type again. So there's that. Now, how should we go about this? Well, we should put um, the new chunk type in the use section, or maybe we do not need a used section in malloc. I guess we can try that next. Since I'm thinking in the free section, well, in the free function, I'll just add the pointer back and try to merge them together in a new malloc function. Though this is gonna get messy. Oops, where am I? Yes, it's the use that I removed. So I can remove this and this as well. But we will add the next one as the next free section, so that is fine. And I wonder what else. I guess we can add a label over here called return, maybe. And actually define return in the top of the function. And if it just returns null, we can just go to the return section. And what else is needed? Yes, we actually do need the data for the previous one. So, well, the previous heap data anyways. Since I want this to be a double linked list, that will make things a bit more convenient at the cost of more memory, though it's not that much. So heap data, call that previous. So libc memory can have null, and we can copy this as well. Instead of d, I guess call this the last one, and this can be null. And while this is going on, the last one can only be set if the next one is not equal to null. I guess, maybe. So if next is null, then that will be the new heap data d. And if it is null, then last would not be set. So I guess that's the logic I want. Just double checking. And then what else? In the next part over here, I have this as a character pointer so that it would just add one. And I guess that is good enough. So how about we try making the free function? Though, just gotta check how much time did we use already. Already 10 minutes for a few changes. I guess I'm thinking a bit too much right now. But thank you for sticking with me this far. And may I see you on the next one.